Welcome to July 5th LeetCode Challenge, longest consecutive sequence. Given an unsorted array of integer nums, return the length of longest consecutive elements sequence. You must write an algorithm that runs a big O of n time. So let's ignore this for now and solve it the best we can and kind of optimize our solution later. So example number 1, we're given an array of nums here. We want to know the longest consecutive element sequence, and that would be the longest consecutive element sequence would be 1, 2, 3, 4, as given in here, and therefore the longest length is 4. Example 2, we're given the array here, and the longest consecutive sequence of elements would be 0, 1, 2, 3, 4, 5, 6, 7, 8. Therefore, the longest element sequence is 9. So the length constraints of the length of nums is between 0 to 10 to the 5, and each index I of nums is between negative 10 to the 9 and 10 to the 9. So let's kind of solve this using a brute force approach first. So because the sequence can start at any number in nums, we want to exhaust the entire search space by building as long a sequence as possible in every number. So meaning that if we just take each number and we just find the number afterwards, if they exist, then we just add that to our sequence. Then we just keep on finding the longest sequence and just find the maximum between our current streak and our maximum longest sequence. So the brute force algorithm is not really special. It just considers every number in the nums as an individual. So it attempts to count as high as possible using that certain number from that specific index. And after each count, we just take basically the max, the current streak we have, and the maximum and the longest streak we have, and then just updates that value which we return, and it just records the length of the sequence larger than the current best. So let's kind of develop that first and then figure out how to optimize it. So say we have something called the longest sequence, called the longest, and assign it to 0. We have something called, next we want to do is iterate for each num in nums. We are going to find the current number, and we're going to assign that to be num. We're going to find the streak, called the streak actually, the current streak, and then we're going to assign that to be 1. And we need to do a while loop to iterate through for each current number. If they have an element afterwards of the current number in nums, that exists in nums, then we want to basically increment the current number we're at. And we want to increment our streak as well. And then we want to, after we exhaust every possible option within the current streak, we exit the while loop, we just find the longest, we update the longest sequence we have. So it'll be the longest, and then the streak we are at. And then we exit that, and then return the longest sequence we have, consecutive sequence. Run this. So this does work. I actually submitted it before, and it gave me a time limit exceeded. Let's kind of optimize this to make this a little better using a set and kind of building the sequence a little bit more intelligently. So it turns out that our brute force approach works pretty well, and it just needs a couple of tweaks here and there to optimize it. So in order to optimize this, we only need to make about 2 changes to the brute force approach, meaning that the first thing we need to do is make a set. So it eliminates like the duplicates that are not needed here. So say we have something called a set. And a set also in Python allows for a big O of constant space lookups. So we only need to attempt to build a sequence from the numbers that are not already in the longest part of the sequence already. So in a brute force approach right here, we basically build the sequence from each number. However, if we use a set, then we know that if 1, 2, 3, 4 are part of the same set, or the same sequence, then we don't need to build a set from 4, 3, or 2, because we know that it's all part of the same longest streak. And then the second thing we want to do is ensure that the number that would immediately precede the element, the current number in the sequence, is not present. So that means that it doesn't necessarily need to be part of the longest sequence. So a couple of the tweaks are that the first thing we do is create a set. So I'll call this num set, and that's going to be a set of nums. And then instead of doing a for loop through nums, we do a for loop through the set of nums, or num set I should say. And then here's the other tweak here. The other tweak is that we have to enter this for loop if the number nums, I should say, minus 1 is not in numSet. Meaning we only enter this loop, this for loop, or everything underneath gets activated only if the number that we counted before is not in numSet. Because if it is, that means we already counted it. So therefore, we still do the same thing. We still update current to current num, still update the streak to make it equal to 1. Still do run this while loop again to find the next element afterwards. Still update increment current, still increment streak, still increment, still update the maximum of the longest. And let's run this code and submit it. Submit. So this will be accepted because I hope. What? What? Why? Oh, right. Well, num in numSet. Alright, this should work. Alright. A lot of things here, but so ideally this looks like time complexity is big O of n. So although the time complexity appears to be quadratic because we have this for loop and this while loop, nested within the while loop nested within the for loop, I should say. If we expect this a little bit closer, we notice that the while loop only reaches the current number that we're at, so which marks the beginning of the sequence. So that means that basically nums minus 1 not in here, we don't actually build a sequence based on that. While the while loop only runs a big O of the while loop only runs n iterations. So through the entire runtime of the algorithm, meaning despite it looking a big O of n times n, it's actually a big O of n plus n, which gives an overall runtime complexity big O of n, as expected, as we wanted. And so the other computation occurs at constant time, so the overall runtime is linear. Space complexity, we do sacrifice a memory because we use a set, so it'd be big O of n as well. Alright, and that is it. Have a great day, guys.